The productivity pressure on sheet metal processing is increasing more and more, and today many laser centers are already automated with automatic loading and unloading. But the shortage of skilled workers is forcing companies to automate further. So today we want to talk about the supreme discipline of automation: automatic sorting. I'm Philip, but I don't want to discuss this alone today. Instead, I've enlisted of our product manager Fabian. And today we're talking about your very own hobby: automated sorting. Hello Philip. Fabian, describe. When we think of our customers today, how do they sort? As you just mentioned, most of our customers have already automated the loading and unloading of the laser. This means that the raw parts already go automatically to the laser, and the cut parts can also be automatically picked up from the laser. The sorting itself then usually takes place at other places, such as belt conveyor systems or carts, where the cut parts are deposited by the unloader and are further sorted there by hand. Where are the challenges? Are our customers happy with it? Is it hard for the people who actually do it? Of course, it has to be said that this work is very dirty and also monotonous. The customers stand at the carts, must bend over them in a very unergonomic position, and do this all day long. This is not a very attractive job. We have brought a video of how we've organized this, here in our production. We also have an automated laser center where one person takes care of the sorting. Can you describe how the process is organized? We see an employee here who is sorting the parts. There are very large and heavy parts there, so a lot of handling is necessary. If you now imagine that there are also a lot of small parts on the plan, he spends a long time sorting these sheets. Let's talk a bit about the personnel requirements. If I have a laser, and automate loading and unloading, how many people do I need for sorting? It's often the case that while the laser is being operated, in example while the laser is cutting, the sheets on the cart can also be picked at the same time. This always depends on how long the working times of the laser are. If a large number of parts are nested, or in the case of fast cutting times, then only one person is no longer sufficient here to be responsible for the laser and the sorting at the same time. Okay, and when the plans get bigger, let's say a second laser gets integrated, how do our customers organize themselves? Then it can be, for example, that one operator is responsible for 2 lasers. Then you really need 1 or 2 people who only take care of sorting the sheets. You've just alluded to it. What solutions are there now? If we say we are actually satisfied with manual sorting, how can I make it easier for my employees? What approaches are there? I can give you an example. We have a solution here, in which the laser is loaded automatically, and the cut parts are then taken to a conveyor system of this type, the loop flex. This is at an ergonomically comfortable height for the operators. The workers can then move all the cut parts to themselves, by the belt, and can sort the parts there more conveniently. So that helps them already. Okay, that's probably especially suitable for smaller parts. Or can you make a general recommendation? Yes, especially with smaller parts, this advantage of advancing the parts is of course even more noticeable. But here, too, larger parts go just as well, of course. Now we've talked a bit about the challenges of manual sorting. But there are also advantages. Quality control is one such keyword, I think. Yes, especially for customers who process stainless steel, for example, and also demand a high level of quality from the material, they naturally want to check again whether the quality is right. This should be taken into account in the overall process, if you want to automate it further. So that's simply something you have to have in mind when you think about the processes, that it's directly included in manual sorting today. This was about helpful tools for manual sorting. If we now think one step further in the direction of automation, what approaches are there on the market? What concepts are on offer? There are various solutions on the market that enable the automatic sorting of individual parts. If you take a look at the product range there, you will see that there are, on the one hand, robotic solutions that use a suction tool or magnetic tool to take the parts away from the sorting table. This can be a decentralized sorting station or directly from the shuttle table. There are gantry systems that can have multiple heads to pick up multiple parts at the same time. And, like our SortFlex, there are cantilever systems that are equipped with a universal tool to move the parts from the shuttle table, or from a sorting station onto the pallets. Okay. These are the general setups. What are the criteria that I have to consider when I want to decide on such a system? So where do I have to look at? You have to think about the overall process in advance. You have to think about the range of parts you have and how heavy the parts are. And there are restrictions on the systems? Exactly. So there's no way that a machine is going to replace employees 100% of the time. There will always be hurdles. There are technological challenges there. And it can always be that these parts cannot be removed automatically, whether they don't work due to the shape, for example, or due to other problems. For example, they are tilted in the laser and are no longer in the intended position where we can grip them. Then, of course, there are always manual interventions required. Okay, the stability of the process is not always ensured, must be looked at closely. What about the speed of the system? Is that an issue that needs to be discussed? Above all, you look at how many parts actually come out on the day, because the speed of the system is always related to how many parts have to be gripped and, of course, transported from A to B. If the cutting times are very fast and there are still a lot of parts, then of course you have to buffer, so that you don't unnecessarily block your laser. So speed still plays a role here. So we have summarized the biggest challenges. I think another thing in Remmert's favor is that we are manufacturer independent. So if you deal with the topic and have decided on a system, we can connect any of them and integrate them into our systems. If we imagine that we are a job shop who wants to get involved with this topic, what do we really have to do in concrete terms to get started with this process? The very first thing we do is look at the spectrum of parts that we want to process. If there are parts that are possibly not so well suited for sorting, because they cannot be picked by the existing tool, or cannot be picked by any tool at all, then these parts can also be technically separated from the nesting plan, in such a way that some nesting plans are provided for the automatic process, and some are still provided for the manual process. That's one issue. And the second issue would be that you have to look at the space in your hall. What space do you have available and where do you place the lasers? Where do you place the automation? And then, here again, there can be different options and solutions that have advantages and disadvantages. Okay, so that's what I got. The easiest way is if I have a lot of the same parts in a restricted size spectrum, then I can start very well with the automated sorting. Otherwise, it's the challenges that you already mentioned that are just technologically based, like canting in the laser, and so on. That complicates the whole process. Let's talk a little bit more about our solution. I think we also have a video how the Remmert solution is used in our own shop floor. Can you describe how we have organized this process? Yes, of course. So here we see a LaserFlex system with connected basic tower which is used for material storage and also buffer storage. We have integrated the SortFlex directly into the system. The LaserFlex automation brings the cut parts from the laser to this sorting station. We can sort the parts from there, but at the same time we can also load the laser with more material, because we have already unloaded it. The sorting is then carried out on the pallets, which are then transported further by the employee via these carts. We are very flexible with this, because even if we are slower with the sorting than the laser cuts, we still have the option of storing cut plans back in the tower, and parking them there until we have time for the sorting. I'll try to filter that a bit. Clearly, the overall advantage of this solution is flexibility, that I can both store back in the tower, but also sort off automatically to relieve my employees. You mentioned the tool. Can you give us a few more details? With the SortFlex, we currently have a universal tool that is capable of gripping and sorting the majority of the part spectrum. This is done because we have a total of 64 different suction cups on it that can be controlled separately. This means that we always compare the geometry of the part with our existing suction cups, and will only activate the suction cups that are necessary for gripping this geometry. Okay, going a little deeper into the numbers again. What spectrum can we cover with the solution, both in terms of the size of the parts and how long it takes per part? So per part we need about 15 to 20 seconds to put the part from the sorting station onto the pallet. It depends on where the part is located on the plan, and how long we spend there with the unit. And in terms of the spectrum, our experience in production is that we can pick 80% of the entire spectrum, and are also successful with 98% of this share. This means that errors caused by the technology happen in 2% of cases, i.e. that one of them tips over or breaks down. What happens if the system can't pick a part? Then, of course, we have the option to skip the part. This means that the SortFlex will try the whole thing twice, and will then move on to the next parts. These parts then of course come out at the end again at the shuttle table, and are then further handled manually. We make sure that the automatic process is not interrupted by a part being left behind. This means that the process is stable. We have to say quite clearly that it is not possible to sort 100% of the parts, but it is very reliable in this spectrum. And if something doesn't fit, the process continues anyway. Exactly. So all in all, we can say that this is a technology with an incredible potential, especially when we think about the shortage of skilled workers, which will certainly continue to grow. That's why it's a topic that needs to be dealt with, and it needs to be dealt with intensively. What is the right solution for you? What suits you? We are happy if we can support you in this, if you contact us and we then work out a solution together. Thank you.